We're going to take a look at section 7.1, some of the takeaways of extended ratios. So if we look at the first example A, it tells us the ratio of the measures of the angles in a triangle is 7 to 12 to 11. And we need to find the measure of each triangle. So we're looking at those angle measures. I'm going to put those in as 7x, 12x, 11x. And what we know about those is that if we look at the interior sum of the angles of a triangle, that has to equal 180. So we're going to take and create an equation, 7x plus 12x plus 11x, and that's going to equal 180. And so we're going to solve this equation combining our like terms. We'll get that 30x is equal to 180, and dividing x is equal to 6, which then tells us that our angles are equal to, if we start here and just do the 7 times x, that's going to be 42 degrees. And 11 times x, 11 times 6, is going to be 66 degrees. And then 12 times 6 is going to give us 72 degrees. And if we look at our second example B, it says the ratio of the measures of the sides in a triangle is 5 to 3 to 9. And the perimeter of the triangle is 68 meters, and we need to find the measure of each side. And so I'm going to take and assign the sides, that this is 5x and 3x and 9x. And I'm told that the perimeter is equal to 68. And so I'm going to create an equation that has 5x plus 3x plus 9x equal to the perimeter, which is 68. And then I'm going to solve that equation, combine my like terms on the left side. 17x equals 68, and divide x will equal 4. And what that will tell us now is that we can figure out our sides. If we take 5 times x, 5 times 4, that's going to give us 20 meters. If we take 3 times x, 3 times 4, that's going to give us 12 meters. And then 9x, 9 times 4, that will give us 36 meters.